Good afternoon, everybody. My name is Jeff. I am the person who has been running this event. So thank you guys for coming. I really appreciate it. Are you guys having a good time so far, everybody? Yeah?
Yeah.
All right, that's good. Thank you. Well, we're happy to have you all here, and I'm very excited to announce our next speaker. This is Dr. Sandy Trautwein from the Long Beach Aquarium.
Thank you. Hello, everyone. How are you today? Good? Well, I'm honored and delighted to be here. This is the first time I've been asked to speak at MACNA, so I finally feel like I made it to the big time. And for those of you, I guess, who thought that I was going to be speaking about habit restoration today, I'm afraid to disappoint you. You can probably find somebody that can help you with your habits here in the audience, but I'm going to be speaking about habitat restoration, so I noticed that misprint. Anyway, I'd like to start by introducing two very important programs that the Aquarium of the Pacific is involved with, involving both invertebrate culture and field conservation. One of them is associated with a federally endangered abalone called the white abalone, and the other is a program that's associated with Sea Corps that focuses on the sexual propagation of two Acropora species that helps with reef restoration in Guam. Now, for those of you that are unfamiliar with the Aquarium of the Pacific, we are located in Long Beach, California, just 2 hours north along the coast. So if you have some time at the end of your conference, we welcome everyone to come and check us out. We are the 5th largest aquarium in the United States with an annual attendance of 1.6 million visitors. And we opened in June of 1998. So this year, we're celebrating our 18th anniversary. Our mission is to instill a sense of wonder, respect, and stewardship for the Pacific Ocean, its inhabitants, and ecosystems. We focus specifically on the Pacific Ocean, and we have 3 primary galleries, one involving the Northern Pacific, so we feature cold water animals like jellies. We also have a Southern California Baja gallery, which features local temperate animals, and a tropical Pacific gallery with tropical fish and invertebrates. We also feature a changing exhibit gallery, a large shark tank, and many different touch labs, including the opportunity to touch rays, sharks, horseshoe crabs, and moon jellies, albeit not all in the same exhibit, of course. Now, as with other zoos and aquariums, the Aquarium of the Pacific is generally considered a place for both entertainment and education. The hope is that we can engage our visitors with live animals, exhibitry, presentations, and education. This combination of entertainment and education generally equates aquariums to natural history museums, but with a live animal collection as opposed to preserved animal collections. Now, very often, zoos and aquariums will provide the very first opportunity that guests of all ages have the opportunity to get up close and personal with wildlife. These memories can instill a sense of curiosity and wonder about the natural world, and sometimes these evocative experiences, especially those associated with touching an animal, can even lead to careers in animal husbandry or aquarium sciences. I know I can certainly attest to that. Now, despite the good intentions of zoos and aquariums, there has been increased public concern about animal welfare, and rightly so. These types of increased pressures certainly have challenged zoos and aquariums to keep pushing the boundaries of animal husbandry and consider what's best for the ambassadors in our care. And while we've come a long way since the very early days of keeping animals at aquariums, there is increasing pressure to become more than just entertainment and education facilities. Now, in order to overcome some of these increasing pressures, many zoos and aquariums now incorporate conservation and research into their goals and their daily operations. Facilities and programs like the Monterey Bay Aquarium Research Institute The Roger Williams University and Rising Tide are working with public aquariums to develop these important programs. And they're doing some amazing things. We've come such a long way, and this is only helping to make aquariums and the hobbyist industry more sustainable. Without these successes, our industry will not have a future. The days of creating an animal collection based solely on wild collected organisms are gone. So aquariums and hobbyists are now working more than ever to subsist on captively propagated organisms and share them among several institutions or individuals. Now, during our 18 years of operation, the Aquarium of the Pacific has developed quite a list of fish and invertebrate captive-bred species. Of course, some of these species are easier to propagate than others, and we by no means culture all of these species on a continuous basis. But we have had a few important successes along the way, including being the first institution to successfully captively raise weedy sea dragons, and the first to successfully propagate zebra sharks using artificial insemination. And we've had our share of successful invertebrate propagation as well, including a few significant species associated with conservation programs. So this afternoon, I'd like to focus on two Acropora species, Acropora digitifera and Acropora abertanoides, that are sexually propagated as part of the Sea Corps program and the federally endangered white abalone through support from NOAA. Now, in both of these programs, the Aquarium of the Pacific is working on culturing particular invertebrates with the hopes of assisting in species recovery and habitat restoration. By combining our culturing skills with field research, we are trying to give back to nature and become more than just entertainment and education facility. So I'd first like to introduce you to our involvement with the White Abalone Recovery Program. I have to admit, before I started working with these guys, I really didn't think too much about abalone, but how can you resist that face? I mean, really, they are so cute. Well, for a snail, I guess, that is. Now, just to give you a little bit of background, there are 7 species of abalone found along the coast of California. As you can see from the map, some of them, like the pinks and the whites, are only found in Southern California and Mexico. Some of them, like black abalone, are only found in intertidal areas, whereas the white abalone, the species that we're interested in, are only found in deeper waters, which of course provides some challenges as far as studying them and learning more about them. All species of abalone, unfortunately, have been overfished. So in California, they are protected, except for the red abalone, which is allowed to be taken recreationally in Northern California. But all of the rest of them have now been protected. Now, abalone have played a major role in California for a long time. The photo in the top left is an abalone shell that was collected from a Native American midden on Santa Cruz Island, one of our offshore islands, and it's estimated to be 7,000 years old. So they've been around for a while. Native Californians have relied on abalone meat for food, of course, but in addition, as jewelry and even currency. The illustration in the top middle depicts Chinese immigrants hand-picking abalone around the 1850s. They would dry the meat and ship it back to markets in China. And even though a commercial industry was closed, the abalone commercial industry was closed back in the mid-90s, abalone aquaculture still persists today and is well worth about $3 million in California. And as I mentioned, recreational diving for red abalone in Northern California is still very important economically to many coastal communities. Now, in the early 20th century, abalone were heavily harvested. This chart shows the progression of techniques that have used from hand-picking abalone all the way through scuba diving in order to access a wide range of depths. Essentially, over time, we were able to harvest deeper and more effectively depleting abalone populations to non-sustainable levels. Overfishing had the most dramatic effect on California abalone, but diseases such as withering foot also contributed to their decline. Now, white abalone in particular were targeted as a delicacy because supposedly they have a very good flavor, a very delicate flavor. I have never tasted them before, but I hear that that was the case for their over-harvesting. So this graph shows the harvests in tens or in the thousands of pounds from 1940 until the fishery was closed in 1997. Essentially, in one decade, between 1970 and 1980, there was a 99% loss of white abalone. The demand for white abalone nearly wiped out the entire population, and what remains is below the baseline for a sustainable population. Now, there are so few individuals left in the wild that the likelihood of a male and female being within reproductive range is nearly zero. Now, because there are so few remaining, the federal government gave white abalone full protection in 2007 when they declared the white abalone to be the first invertebrate to be listed on the endangered species list. Historically, they are a deeper water species, with most of the remaining individuals now living below 100 feet in depth. Again, it makes it challenging for scuba divers to study or even find them, and ROVs are often used to help find the remaining individuals. Their maximum size is about 8 to 10 inches, and they live an average of about 30 to 45 years, which really surprised me. Unfortunately, there are still poachers and environmental threats, so their populations continue to decline. So in 2010, the Aquarium of the Pacific received funding to help with the white abalone recovery plan through NOAA. We work with the Bodega Marine Lab and a consortium of partners whose primary goal is to ensure the recovery of white abalone populations throughout its range in Southern California and the establishment of a self-sustaining population. The Aquarium of the Pacific's specific role is to culture white abalone and to help with their outplanting. So once the recovery program was initiated, one of the first tasks for NOAA was to establish a captive breeding program for them. At that time, there were only 75 white abalone adults held in captivity that could be used for broodstock, and all were being held at one facility. So one of the first tasks for NOAA was to try to distribute these abalone to different facilities so there was a higher chance of their survival. Heaven forbid something would happen at that one facility and wipe out the only 75 white abalone left in captivity. In addition to this, all of the white abalone that were left, the 75, they were all related to one another as they were produced from a single spawning back in 2001. So right away, we're faced with some challenges in trying to propagate these animals. So the Aquarium of the Pacific received several white abalone adults, and one of our first tasks was to sex them. Now, this is not an easy task for white abalone. You gently peel back the mantle, as you can see here, and their reproductive organ is located along the base of the shell. And if it's a cream colored, then it's usually a male due to the sperm, and if it's brown or greenish color, then it's usually a female. But that's not always the case. So we initially guessed what their sex was, but we really didn't know until we actually spawned them. and only if they were willing to release their eggs or sperm did we confirm their sex. Now, reproductive condition has a lot to do with their nutrition, so we do collect live giant kelp for them on a regular basis. They love this and other brown algae like laminaria. But the juveniles are usually fed dulse, a red algae that's higher in protein and supposedly more nutritional than the brown algae. So with funding from NOAA, the Aquarium of the Pacific was able to build a small culture system for spawning and settling white abalone. You can see the long troughs on the left-hand side of the slide. That's where we actually settle the juvenile larvae. And on the right-hand side, we use that space for the actual spawning. Now, this is a completely closed system. It's the only closed abalone system in the state of California. All of the other facilities have open system, which is great if you want natural seawater and free-flowing, but it also provides some challenges as far as temperature fluctuation, especially since we've experienced a high El Nino this year where the water has been extremely warm. So we're able to control temperature in our system. We usually keep it within the normal range for abalone, which is between 54 and 64 degrees. And we do vary the temperature and the photoperiod to match that of Southern California so that we can simulate their natural cues that they would get in the wild. So the abalone life cycle has two basic parts. One is a planktonic stage where they're free swimming in the water. This lasts about 1 to 2 weeks depending on the species and the temperature. And then there's a benthic stage where they actually start crawling around and looking like a snail. Some species, like red abalone, can spawn multiple times a year, whereas others, like the white abalone, unfortunately only have a small window in which they spawn in the spring once a year. So that's our only shot to try to captively propagate these guys. So out in the wild, eggs and sperm will be released into the water column. The sperm will fertilize the eggs. They'll have this period of free-floating trochophore larvae that you can see in the picture on the right, where they do have a crown of cilia that help them stay swimming in the water column. Then, after a period of time, they'll begin to test the bottom actually looking for CCA, or crustose coralline algae, as a cue, meaning that that's a healthy environment and that's where they want to settle. So once they settle, their first food is generally diatoms. They eat them in great numbers. So at the Aquarium of the Pacific on spawning day, what we do is we generally pop off the white abs, which is difficult in itself. Someone usually has to crawl in the tank to do that. But we also give them an initial exam. We pull them out, we weigh them, we measure them, and we check their gonads for a particular score. So if their reproductive organ is really shrunken down, it will get a score of 0. If it's really robust and full, then it will receive a score of 3. And most of the time, you expect those with a score of 3 to be the ones that are likely to spawn, and the ones that with sort of weak gonads usually don't spawn. But we found just the opposite, and sometimes even those animals that have a score of 0 or 1 will sometimes produce millions of eggs. And when they spawn, they really go off. During spawning, we will isolate each individual in a spawning bucket, and we'll add a highly oxidative substance, such as hydrogen peroxide, and a little bit of buffer to keep the water the pH just right. And we keep it in a water bath. We start early in the morning, like 5 or 6 o'clock, and then we let them sort of soak in this concoction for a couple of hours. After a period of time, they'll begin to release gametes, and then we quickly change the water to get out that hydrogen peroxide and put fresh seawater in their buckets. and then we can begin to collect the eggs and sperm from each individual. With the sperm, you can see the picture on the lower right, where we actually withdraw it is exactly from the respiratory pore, so it doesn't get diluted in the water. So we're syringing that out, basically, putting it in vials, and then keeping it on ice, because oftentimes males and females will not spawn exactly at the same time. But we only have a very small window because either the eggs or the sperm could be sitting around and then not be viable if it gets any later than a couple of hours or more. So we collect the gametes, we mix them together, and in this way, although they're all related, we can try to maximize genetic diversity by doing our own cross-fertilizations. So once the eggs are fertilized, they flow from trays that are located on the top shelf of that system into specialized buckets that you see here on the left. These buckets are designed so that we can do water changes without harming the larvae. They'll have to stay in these buckets for about a week while they go through that development period. So during this period, we don't want to handle them or use any nets or even siphon tubes to try to do the water changes because it can damage them. We also check the larvae very frequently under the microscope to make sure that they're developing properly. And what we're looking for is a trochophore larvae, where they begin to develop a shell and an operculum and begin to look like a snail. Now, when we see the larvae reaching that veliger stage, that's the stage where they begin to sort of develop the shell and the operculum, then we do competency tests to make sure that they're ready to settle. When we see the tiny veligers, we will put a piece of CCA, a little chip of coralline algae, in a petri dish with some larvae. And if they begin to start crawling around on that little piece, we know that they're ready to settle. But again, not all of them are going to settle at the same time. So we use a product called GABA. This is really interesting because this is a product that is produced by our own brains that helps to reduce stress and relieve anxiety in humans. So what they've found is evidently it not only works on humans but also abalone. You can add a little bit of this to the larvae and the water, and it helps the larvae settle. So once you add the GABA, then we pour the larvae into these troughs that have tiles on them, and the tiles have diatoms, a very thin brown layer that you can see in the bottom right. And this will be our baby abalone's first food. Now, after the spawning, once we've finished and we have them all taken care of, we take the adults and we give them a spa treatment. They enjoy a lovely combination of coconut oil and the finest beeswax, which we melt and then paint on their shells. And this sounds like we're actually torturing them, but what it does is it prevents boring sponges and also sabellid worms and other organisms from infiltrating the shell, which can actually kill them. So we give them their spa treatment, and then we let them rest and sort of work on, again, reproductively conditioning over the next year when we will try to spawn them again. And there they are getting their spa wax treatment. Now, since the inception of the program, the Aquarium of the Pacific has had a successful spawning event every year. After we pour those larvae into the troughs, we're never really sure we're successful or not until a couple of months later. You can see in the upper right just how small those little guys are. They're like microscopic specks. So you just keep your fingers crossed and you hope that you have been successful. And in a couple of months, we should see little halos in that layer of diatoms that indicates that our baby abalone are eating. Now, due to the space constraints at the Aquarium of the Pacific, most of the white abalone that we have produced have been raised at the Bodega Bay Marine Lab. And to date, we have contributed thousands of white abalone to this program. To date, there are some 4,000 juvenile white abalone that have been growing and thriving from this program. Some of these juveniles will be used for future broodstock, while others will be used for outplanting. And that is the next stage, is the outplanting. Now that we've produced thousands of juveniles, we are working on testing the outplanting of abalone. So no white abalone have yet been outplanted in the field, but the Aquarium of the Pacific is currently participating in a pilot study involving red abalone, where we're using these abalone recruitment modules, which you see on the lower right there. These are simply cinder blocks put together in a maze fashion and then covered with sort of a netting or some sort of material to protect a lot of predators or larger predators from entering that recruitment module. And the baby abalone are simply released into this module where they can receive some initial protection during the first few months of development until they're ready to begin crawling off and eating and exploring on their own. So the results of these pilot studies will be used to help us determine what size, because that's really the key now. There's a lot of pressure to get white abalone back into the field, and we've only been doing this a couple of years. So the size at which we do it is pretty critical. I'm suggesting that we grow them up to about this big before they go out, but I think NOAA has different plans. So we'll probably be outplanting them in the next couple of years or so. So at this point, it's hard to predict whether the white abalone populations will ever reach previous levels. We certainly hope to see large adults like this in the wild again, but it's still kind of unknown. In the meantime, the Aquarium of the Pacific is proud to be working in that direction. So for the rest of the talk, I would like to turn your attention to another project at the Aquarium of the Pacific. We are involved with Seacorps International, a nonprofit organization that is based out of Germany. You may have heard previous talks about Seacorps from Mitch Carl or from Jamie Craggs or even the president of Seacorps, Dirk Peterson. They have been around for a few years now, and they typically hold workshops in Curacao, Mexico, the Bahamas, the Philippines, and Guam. Their goal is to assist in coral reef restoration by sexually propagating corals and thus increasing genetic diversity and outplanting specially designed tiles like the one that you see there on the upper right. Since 2013, the Aquarium of the Pacific has participated in Project Guam. Guam's reefs are particularly in peril due to climate change and outbreaks of the crown of thorns sea star. We previously participated in the large workshops in Guam, but this year was a little different, and we had a very unique opportunity to work with a small crowd. Usually the typical Seacorps workshop is probably like 30 people or more, ranging from park managers to aquarium staff and even coral reef biologists that are all interested in coral reef restoration. This year it was just a smaller group involving the Aquarium of the Pacific and the underwater world in Guam, an aquarium there, and the University of Guam Marine Lab. We decided, even though that there wasn't an official Seacorps workshop happening in Guam, that we would go there and take advantage of the annual Acropora Spawning event. So we worked with 3 different Acropora species: Acropora digitifera, Acropora abracinoides, and Acropora circulosa. It seems that these 3 species generally spawn once a year all around the same time in July. So we were recently there just a couple of months ago. Now, as you know, coral spawning is generally tied to the lunar cycle, and colonies of the same species will synchronously spawn throughout the evening hours. Seacorps has developed a method for capturing the gametes, or the egg-sperm bundles, by using these specialized cone-shaped nets that you see in the upper right. At the end of those nets is a collection cup. So during the spawning event, the nets are placed over the colonies, And then because the egg sperm bundles will float, they're captured in those collection cups. We then bring those gametes back to the lab where we can do controlled cross-fertilizations. It is just amazing. If you've never witnessed a coral spawning event, I definitely recommend trying to get to a place that has that, because it just happens, and it happens with such, it's just amazing to me that these colonies expend so much energy, and to think that they've been doing, preparing for it all year and sending all of their energy into this reproductive mode just for 15 or 20 minutes of releasing their gametes. And then when you come up after the night dive, you're just in a thick layer of coral spawn with both these egg sperm bundles. And out in the wild, this will get washed around in the waves, and the egg sperm bundles separate and they cross-fertilize, and then they just drift out in the ocean. And we hope that some of them make it, of course. So in addition to collecting the spawn from the field, we also have broodstock colonies back at the lab. And after we collect the egg sperm bundles from both the field colonies and the lab colonies, we'll again cross-fertilize them so that we can make sure we're not putting sperm from the same colony to eggs with the same colony. So then it gets a little crazy during spawning nights because we go late into those evenings, but basically we check the fertilized eggs under the scope, and we do that throughout that same spawning night to make sure that the cells are dividing, as you see in the upper right. Once we're sure that the cells are dividing and we have at least 80% of the eggs are fertilized, we'll then pour those fertilized eggs into a static trough. So this is, it doesn't have any water flow, it's just fresh seawater straight off the reef. The one thing I was really surprised about is that, I've always kept corals at the aquarium in the Pacific around 78 to 80 degrees Fahrenheit. The water was 84 degrees here and would sometimes go up to 90 on certain days. So the water is extremely warm on some of these places. I'm not sure if it's associated with climate change or if that's what happens normally, but we had to keep everything at about 84 to 86 degrees. Then we watch the free-floating larvae for the next few days and monitor their development. As I said, the cells divide, but they also go through this planktonic prawn chip stage where they are very fragile, and again, you don't want to handle them during this time. What we're hoping for is to get this planula larvae at the bottom that's circled in red. This is the larvae, like any other cnidarian larvae, that begins to settle down and hunt on the bottom, looking for the proper substrate to begin depositing its skeleton and begin to grow. If there's one thing I could do with folks that are visiting the Aquarium of the Pacific is to show them this planular stage, because it's then that you can truly see that corals are animals. They really do actively hunt. So we check them every day and night, watching their development, even doing water changes, and even using saran wrap, supposedly, in the bottom right picture, which we were doing there. Since not all of the eggs get fertilized, some of those unfertilized eggs will begin to decompose over the course of the week. So because those decomposing eggs are fatty, they'll float to the surface of the water. And our German research friends there showed us that you can actually take cling wrap or saran wrap, put it on the surface of the water and sort of peel it off. And along with it will come all of the fat, but it will leave the healthy coral larvae behind. So we did that day and night as well in order to make sure that the static cultures, again, were healthy and clean. Once we see the larvae beginning to test the bottom, even here, as you can see in the upper left, they'll use a piece of plastic that was floating around in the trough. We'll add, again, chips of CCA to a petri dish with some larvae, and watch them settle. If we see them actually settling, we know that they're ready for settlement in the troughs. Now is when we go to our C-core tiles. These are specially designed tiles that have been conditioning out in the field for the past year. And they should have a nice layer of crustose coral and algae again on them. They should be nice and pink. You can see in the upper right, some of them have been conditioned and some of them have not. So we want to use the ones that have definitely been conditioned and then add them to our troughs. Once the tiles are added to the troughs, we wait to see their development. And again, this is one of those moments where we really don't know whether it's worked or not. But then we begin to look at the tiles under the scope or with a flashlight and a very high-powered camera, and you can begin to see the specks or the coral spat where it's actually settled on the tiles. So these are our tiny new corals. Most of these tiles will be then placed out in a field nursery. You can see there's Dirk Peterson in the upper left. And that's where the corals will grow and be ready for outplanting 1 year later. And when we return the following year, then we begin to outplant them like Danny is doing there on the right-hand slide. And these tiles are specially designed to be actually dropped from a boat. So the hope is that we get a bunch of these tiles. We have coral spat all over them. We take our little boat out over the reef and we just chuck them off the side of the boat. Hopefully they land in a crevice and then corals begin to grow. And this is a way that we can hopefully repopulate and restore reefs that have been damaged in the past. I was delighted to see that some of the tiles that we had outplanted in 2014 up in the right-hand corner are now growing and thriving on the reef. And you can see the small coral on the bottom right there. That's an Acropora circulosa that we had outplanted in that same spot in 2014. And you can't see it there, but I've got a big grin on my face because I'm super happy that it shows that they're growing out there, and we're contributing to reef restoration in this way. Now this year we were especially delighted because it was the first year that we could actually bring some of these tiles back to the Aquarium of the Pacific. We brought several tiles back from each species, and we also, surprisingly, I didn't know this, but you can keep the unsettled larvae alive for up to a week after you, I think maybe even longer, someone told me, for up to a week. As long as you don't have any cues for them to settle, you can keep them in that free-floating stage. So we brought back some in some soda bottles, and we took some chips of CCA that we actually brought back from Guam. We broke them up, and then we actually settled the unsettled larvae back at the Aquarium of the Pacific. So that was really exciting for us. And if you do get a chance to go to the Aquarium of the Pacific, you'll be able to see a small exhibit currently behind the scenes with our C-core tiles and our little coral spat. We are hoping to create a new exhibit about this work and about the progress with our corals here. So we're super delighted about it being involved with this work. So that's about the end of my talk. I just want to give a shout out to CCA. I had always loved CCA and had great respect for it because it is beautiful in my mind. And I do think that it indicates a very healthy environment, whether it's in an aquarium or out in the field. So I gained that much more respect for it after working with these two species and discovering that it is an important settlement queue for both abalone and for corals. So if you got it, then great. Keep it going, because I think it's awesome. I'll let you decide which of these sunsets is from Southern California and which one is from Guam. I know there's no contest there, but they're equally beautiful in their own way. I would like to acknowledge NOAA, Bodega Bay, Sea Corps International, Underwater World Guam, and the folks from the Aquarium of the Pacific, Perry Hampton, Danny Munoz, Janet Monday, Chris Plant, Alex Lawler, and Jay Harvey that are part of these teams. I'd also like to thank Maureen Mola and Sam Niza. These are the two researchers from Germany that are working on their PhD in reef restoration, and they are awesome. We seriously could not have been so successful this year without their help. And of course, our abalone guru, Kristen Aguilino from the Bodega Bay Marine Lab. So thank you, and thanks to MACNA for having me.